I'm going to introduce our plenary speaker for today's symposium, a dear friend, colleague, and mentor of mine, Rob Socolow. Rob is an emeritus professor from the Department of Mechanical and Aerospace Engineering at Princeton University, right down the road. He earned his PhD from Harvard University in theoretical high-energy physics in 1964, was an assistant professor of physics at Yale University from 1966 to 1971, and joined the Princeton faculty in 1971 with the assignment of inventing interdisciplinary environmental research. And from 2000 to 2019, Rob and Steve Pacolo were the co-principal investigators of Princeton's Carbon Mitigation Initiative. Some of you may be familiar with one of Rob's best-known papers that he published with Steve Pacolo in 2004, Stabilization Wedges, Solving the Climate Problem for the Next 50 Years with Current Technologies. And this was 2 decades ago. I met Rob in 2009, 2010 timeframe, where I worked as part of a broader team on an American Physical Society assessment that Rob led on direct air capture of CO2 with chemicals. At that time, we were just trying to understand the technical feasibility and what it might cost. Rob has served as both a mentor, a dear friend of mine ever since, and so we're really fortunate to have you here today, Rob.
Wonderful introduction, Jen. Roger Ains was here also, was another member of our group sponsored by the American Physical Society. And we were downers about direct air capture. I think we actually made up the phrase direct air capture. I think we decided to put a name on what we were studying, and it hadn't existed before. We thought it was awfully expensive. And I'll say more about one of the major distractions to our thinking, which is we need to return to again. So I've made up this title, Living Creatively on a Small Planet. Every one of those words matters, right? Living, for sure, and creatively, small. And so a lot of this started, there was a start to environmentalism. And it really was, I think, related to the space program and to looking at the planet from outside and realizing it was isolated and it was ours, and that we really could lose it. It was vulnerable. And then we started talking about what we would need to make it a wholesome place to live. And I'm going to go fast because this is a sophisticated audience. They've seen many of these concepts. But I like to make up slides, and they're a little different from what you've seen, and you're welcome to borrow any and all of them. My simple representation of what people are trying to do now essentially is run the fossil era backwards. It took about 80 years. Schematically, there's a relationship between total carbon emissions and temperature rise, which is roughly, poetic license, 1,600 billion tons of CO2 goes with 1 degree Celsius of temperature rise. And that's a triangle which is 40 high and 80 wide, where 80 is years and 40 is billion tons of CO2. We're in the high 30s with CO2. We're above 30, we're above 40 if you add other gases. And if we want to stick to 2 degrees, one way to do it is to take the same next 80 years, starting around now, and run it down. And 40 years from now, mid-century, be about halfway down. And that's approximately the 2 degree future. 1.5 degree future, you go all the way down in 40 years. So it's a schematic that kind of gets your bearings. And of course, all of this is global. And one of the things that you have to think about for round 2 of your current study, which is all about the US, is what's the game plan for making everything you learn global? How do people internalize? How are you going to get the information out? What's wrong? What needs to be tweaked or quite substantially revised in order to be useful, and so on. It's really so important. We are 5 out of 40 and the global emissions of gigatons of carbon, so under 15%. And that fraction's been dropping. It was about 50% at the end of the Second World War. Slowly, steadily going down, the American relative to the rest of the world. I just said that. And here's a schematic for what we're doing. This is the present economy. Carbon is extracted from the earth, popped into the atmosphere. In between, it's gone from reduced to chemically oxidized, and the energy is extracted. There are 2 separate choices, oxidizing it and using it in the first place, And where are we going to put the waste product? We don't have to put it in the atmosphere. So the negative carbon that you're primarily looking at essentially is running those 2 arrows backwards. It doesn't directly affect the economy because it's coming out oxidized and it's oxidized all the way through. But there are two other versions. One is the fossil CCS world, where we continue to take CO2 out of the ground. We just don't let it go to the atmosphere. We interrupt it. And the other is that we want to have fuels and such in our lives. So we actually reduce the carbon dioxide and then we use it and it goes oxidized again and back to the atmosphere. Those are both neutral, not negative, not positive, but neutral. And we're finding our way through there. The one on the lower left is the one I personally spent a quarter of a century promoting, thinking it was absolutely central to the low carbon economy. And the word CCS meant 10 years ago, fossil carbon capture and storage. It did not mean air capture and storage. And it glided from one definition to the other with very little notice. So that today, if you hear the word capture and storage, you probably are hearing people talking about air capture. And that's kind of interesting. So why did air CCS become so attractive and so fast? One is that it is exciting, novel for a new guy on the block, new gal on the block, and is needed for net zero. Net zero means positives and negatives cancel. And then a second reason, I think maybe really important, you guys in each judge and tell me yourselves, it doesn't sound like it has fossil fuels in it. However, who's going to do the job of managing all this gas injection below ground and monitoring it, seeing where it goes, where it was a good place to put it in the first place? And is that a bad or a good thing that their fossil energy industry might play a major role anyhow? To hide it from ourselves is not smart. So in some of the scenarios that have been done all over the world, both air CCS and fossil CCS, I'm putting a prefix in front of them now, are present and substantially present, with fossil playing an early role. That's a picture that's widely shown. And the fact that I'm now using these prefixes, fossil CCS and air CCS, can lead to a fun game where you say something was used without a prefix before, then a new thing came along, and then we had to modify the thing originally. So my example is acoustic guitar. So a guitar was a guitar. Then came electronic music, and we need acoustic guitar, natural foods. And you can make an interesting list of these. So in the midst of the quarter century I'm describing, when lots of people worked on capturing CO2 from fossil fuels, including coal and only gas. This is a picture from the 2005 Scientific American, and I wrote this paper, but I had a huge amount of help from a large community, which was thinking about what this would all look like. And the question was, how much CO2 you're generating? If you put it below ground, what areas does it occupy? What area times thickness does it occupy in the formations? And this was a calculation that hadn't been done before. And the picture was new for this. And I think Julio helped me with this, but many of the leaders of the fossil world were engaged in this picture. And the question in front of us today, and I want to make this important for the conversation, is should fossil energy, or even must fossil fuel energy, be phased out as part of the low carbon world? We are implicitly saying yes in many of the ways in which we're thinking about the problem right now. But fossil CCS is another story. Whether it's fossil CCS or air CCS, these are energy intensive occupations. And another thing, you all know this, but I call it the 1/1 minus X rule. X is the CO2 that goes into the atmosphere doing the job of capturing, divided by the amount that you captured. And if X equals 1, the ratio is infinity. That means we're putting 1 CO2 in the atmosphere for everyone we're taking out, and we're accomplishing exactly nothing. So it is not at all easy, especially with air capture, to have a small value of X. And one of the things is we don't have to be too greedy and want to do it immediately, but it will make no sense as a major contribution to a low carbon global economy if we haven't got X very small. So today people know that. And one of the things they do is they have a dedicated low carbon facility. Maybe it's a big solar field. Maybe it's natural gas captured the way I was talking about. And when you do, you raise the question of what I call opportunity cost. We have a coal plant. In fact, this is somewhat true in Bison and Wyoming, if I have it right. There's not too far away, there's a coal plant. There's an air capture plant, and there's a solar field to power the air capture plant. Instead, the renewables facility could close down the coal plant and and you wouldn't have any air capture facility. So that's the competitor, the opportunity cost, versus leaving the coal plant alone, powering the air capture plant. So we have to be very conscious of that. Again, not immediately. We have an R&D program first, but that's where it's going. Again, no matter how whether you're capturing CO2 from the air or from fossil fuels, you have another problem, which is we're putting, for every 2 tons of CO2 we're putting into the atmosphere today, only 1 is staying in the atmosphere. The conversion is about 8 billion tons of CO2 is 1 ppm. We're putting about 15 into the atmosphere. Is that the right number? And it's going up by, I'm doing this in my head, 1. But so this is roughly this is a particular curve fitting from a while back, but it's still true. Half the carbon goes in the atmosphere, about a quarter goes into the oceans, making it more acidic, and a quarter is making more robust vegetation, mostly in forests. If we run it backwards, we'll have to take 2 billion tons of carbon or 8 billion tons of CO2 out of the air, which in order to get 1 ppm reduction of the atmospheric CO2. That makes the job harder. We can't really hide that we also don't know the fraction as well as we should. We should be pressing the climate modelers to work this problem a little harder, but we don't know that much about how the vegetation really will behave. The ocean is better understood, I think, but even there, so there's more work to do. So this is another of the conceptual frontiers of our subject. And then we're going to put the CO2 below ground. Not necessarily, but it's one of the destinations. Obviously, building up vegetation is a great idea too. Getting it into rocks is a great idea too. But if it's going to go below ground, I have this little picture to share with you, which is the carbon is coming out of the ground with hydrogens attached. CH2 is approximately what oil is. And then it's going to go back in the ground with oxygens attached, which are much bigger atoms. I talk about you walk into a restaurant with two kids on your shoulders, and you're walking out with 2 bodyguards. And the conversion there is that 1 billion tons of CO2 per year, which is kind of kind of a figure of merit for the whole U.S. enterprise at the present time, is equivalent to 30 million barrels a day in volume flow, when you use a density of 0.6 of the density of water, specific gravity, which is not a bad number to use. It depends on pressures and temperatures, but supercritical CO2. So 30 million barrels a day. The world oil trade is 100 million barrels a day. World oil trade. US is 20. So that is a huge volume flow, and we're talking about building it. We can only, it's like building the highway system or the electricity system. And we're not really talking about that. We're talking about projects for the most part still. So that's another part of the story. And once it's down, we have an interesting ethical issue about how long it has to stay down to be a win. And we have, again, that's kind of vanishing as a conversation. It was more on our minds a decade ago, I think. You can overdo it. You can get too greedy. I think the nuclear waste people in the 40s, and no one has told this story, got very greedy about how long they could keep the waste isolated. And then the B teams were given the job of challenging the A team's reasoning, and they could always find loopholes, ways in which it could escape the nuclear waste. So you've got to be very careful not to get too greedy here. We don't need to stay 10,000 years, I think. And then we have an interesting new competitor, even newer to the ballgame than the air capture, which is geoengineering, solar geoengineering, solar radiation management, albedo management, various names for the same thing, which is that we're going to get roughly 31% of the sunlight gets reflected off the tops of clouds and ice and whatnot. And if we had 32%, we would be canceling a lot of the warming. That's about the numbers. And we can do that. We think we can do that. We think there's another group of people, some of you may be doing both. And there may be down the hall, if you're in a national lab, who are trying to figure out how to make this work. And it's more problematic, more people are scared of it, but it's in some sense a competitor. It's a way in which we cancel, somewhat we're canceling in a different way, but we're canceling the warming we're doing with greenhouse gases. And so the question is how to think about that competition. And one of the pictures that people refer to when they think about this is that the solar engineering is going to arrive because we can't get CO2 capture from air fast enough. We'll need 50 to 100 years to get that job done. And meanwhile, we'll have the solar reflection to keep the temperature from going too high, kind of cut off the peak. And then it will have served its purpose. CO2 removal will be alive and very well, and we can phase out geoengineering. It won't be part of the 23rd century. I find that extremely hard to believe. I don't think geoengineering is going to, if it comes, will be easy to get rid of because it will be doing useful things. So I think this picture is a fantasy on the part of the geoengineering folk who wanted to scare people too much. But I think, frankly, that it will be, if it's a kind of decision in the next decade or so, about how fast to go forward, because we won't, if we get started, it's going to be addictive. Now, that's again an opinion, but this is not the way, this is the more, what I have in front of you is the more usual picture. All of these technologies have downsides. There's nothing surprising or unusual. Solar has this land impact, which is immense, particularly for those who care about wilderness. They kind of moan the arrival of a solar field rather than cheering it on. And right down the list, solar there can be too much regimentation with, we had even a somewhat famous man was saying we shouldn't ban light bulbs that are incandescent not so long ago. And on and on. Nuclear is the one that many of us with science backgrounds have been trying to position ourselves on nuclear for my case, for half a century with colleagues who study it professionally. And it's the connection to the nuclear materials, the plutonium and the enriched uranium, to war that make us hesitant globally. A global technology, not a US tech, a global technology, which is replete with plutonium in the marketplace and so forth. Very, very scary. And under carbon capture from air, I said net carbon shortfall. This is the net carbon 1 over 1 minus X story. And then I could have many other things on that list. Solar deficiencies, thinking somewhat more about the biocarbon, negative carbon when I write that storage deficiencies. What exactly are we doing when we're putting extra carbon into vegetation in various places? Really concerned. So to explain what I mean by conditionality, which is a word used in international diplomacy for agreements, we'll allow this only if that. Is to give you a little game where I want you to be a forester or an agronomist, and there is a carbon price that is very high, and you have a boss who's interested in making money, and you are told to store carbon, and there are no rules whatsoever. What would you do? And then really be imaginative. Get all the people off the land, fertilize the heck out of it, go to monospecies, do a variety of things. Now take a different job. Many of you have that job. You're the policymaker setting up the rules. You see what will be done if you don't tell businesses what to do. What would you put in there? This is the game. Businesses do what they're required to do. And some of you are involved in making the rules up, so not inventing them, creating those productive rules. So my friend Hippocrates, in one modern form of the oath, is envisioning very strong drugs, which are going to have their own side effects, but maybe will make the patient better. And the way that it is put in, it is actual verbatim from one version of the Hippocratic Oath. I will apply for the benefit of the sick all measures that are required, avoiding those twin traps of overtreatment and therapeutic nihilism. To me, that captures what the dilemma is with these various technologies that we have. And then in effect, that's important because it can't be a single goal of just having the lowest possible CO2. Rather that we have a two-sided reasoning, which takes into account the defects of the solutions, and they all have defects. We're thinking globally. It's not comfortable. We're a nation-state organized world. It's in the way, that's organization, of getting the kinds of problems we have in front of us solved. We have to figure out how to deal with that. The United Nations in 1945 was part of a whole way of thinking that we could indeed have lots of multinational institutions that would be productive and would erode sovereignty somewhat. And it doesn't. I don't have to tell you. I mean, we have to explain to lots of lay people how the atmosphere works, but we're all in this together. And I've made up a name for what we're really talking about here, which is destiny studies. It's the collective survival and flourishing of the species, of us. We have, philosophers have forced us to, or others too, if we had just the beetles left, would that be a world that we would be satisfied to have brought about? And if the answer is no, well, how come? And we have to unpack that. I think there's the makings of a kind of a ecological religion around the principle that this collective survival and flourishing of the human species is what we're really all about. And people will challenge that, say, no, I think it has to be an axiom. I don't think you can derive it from anything else. So how soon will there be a program in destiny studies at your institution?
We have some questions from our virtual audience that will start off. And if anyone here has a question, raise your hand and we'll bring the microphone over to you.
All right, great. So our first question from our virtual audience is, can you share your speculation about how the upcoming national election will impact this effort?
You guys know at least as much as I do about that. I'm inclined to say it's got to be longer than 4 years or 8 years that we're talking about. So what is the impact of the next election on the one after that, if there is one? And what is the capacity to solve problems that is going to be developing? We do a lot productively when we have a hostile environment, as well as when we have a generous one. So part of me, Mondays, Wednesdays, and Fridays, and today's Wednesday, I get really scared about a Trump administration just undermining everything we're trying to do. The guy says he has an uncle who was a professor at MIT, and he got very respectful of science. And there's a Tuesdays, Thursdays, and Saturdays. I guess I'm not quite so sad.
All right, we have another question from the online audience. So speaking of the online audience, people are tuning in from all over, and they're wondering if you can say anything about the online carbon footprint. Is attending online resulting in CO2 emissions as well? I think that's to what Jen
That's a
put
great question,
online.
and I hope somebody's calculating it. You can do it. I mean, we're talking about the enormous energy demands of the AI, and we've known. I remember really making young people quite unhappy when I was working in energy and buildings. I was saying, you know, the lighting is being overtaken by your electronics in terms of the demand on electricity in your house. Oh, no, we love our computers. No. And then similarly, some of the international set not wanting to hear about airplanes. You know, it's real. How big it is, it's certainly less than flying over here. I think we're pretty sure of that calculation by maybe at least one order of magnitude, if I had to guess. But it's a really good calculation. I think it's an example of the kind of calculation we can do, and we should know the answer. And if maybe one of you does know the answer, maybe you've done the calculation. Anyone? No, it doesn't look that way. Next.
So hi, Rob, it's Julio. I do not know the answer. Thank you for an outstanding talk as always. In addition to profound and rapid reductions and enormous volumes of removal, we also have to make stuff. We have to create the built world. We have cement, steel, concrete, fertilizer, fuels, all of these things. How is it that we start talking in the context of destiny studies or about the just, verdant world we want to build? How is it we start talking about the manufacture of clean products?
Well, it's critical. I mean, you know, the pattern of development of a country like China was enormous amounts of emissions, a very steep rise as they built the roads, the ports, and the buildings. That comes first. And the CO2 infrastructure we're talking about of pipelines all around the country is itself going to be very substantial in its resource demands. We can do that in a low carbon way so that the X doesn't get too big is a real challenge. And I think some of you working on mineral CO2 capture, it may be to build up the CO2 pipeline that those pipes are going to get. The cement pipes will be used on. Maybe they have to be metal. I'm not sure. That's already a question. Maybe you line them. Maybe that's how you do it. Yeah. Julio, would you add to that? You probably know a lot about it yourself.
Well, I have some opinions, but it's starting to occur to me this is missing from the conversation. So we're framing this entirely as we got to mitigate climate, as opposed to we got to mitigate climate and build the world we want. And I find building the world we want is honestly secondary.
No, so they go to. Well, and the developing countries clearly don't like the world they have. They're not even close to wanting to stay where they are. And that's where the growth is coming from, especially. So focus on at least three quarters of your effort on where that's going to go.
I think I'm our final question, no pressure. When you think about atmospheric engineering, I know that's such high risk. Do you think there's a milestone, 10 years, 50 years, 100 years, 200 years down the line where we start considering it? Or do you think it's absolutely not, never?
Well, it depends on who you hang around with, what you hear. But I think people think we have an order. If the lay folk would let the experts have their way, they would have an orderly progression of learning that would be quite fast. Because the instruments delivering the aerosols, seeing what they do in this strat, they've got a list of things to worry about. They want to cut it down. To me, but some of the most interesting conversations are, it's not even worth thinking about because governance is impossible. That's what I've heard from some atmospheric scientists who don't like it. Is that true? It's certainly a big challenge to figure out how to organize the planet to run that. But the same thing goes for CO2 removal. To some extent, you can do something in your own country without so much fuss. But unless everybody's sort of working together on it with a certain pace and sharing the job, I don't think we'll amount to very much. But I think governance is much harder for solar radiation management. But the technical side, I don't think I think it can be done. I think the way to think about it, then there's more than one way to do it. The stratospheric aerosol is probably the best. But these experiments are not being allowed to happen. I think you all know that. Public resistance, which is the number 5 in your 6 panels, if I have it right, is alive and well. Thanks.